Hi, my name is Milan, and in this video I want to show you how you can naturally evolve your domain model to start using domain-driven design principles. The approach that we are going to explore is starting from a complicated transaction script implementation, carving out a potential aggregate, and then using this aggregate to encapsulate our business invariants and protecting the access to the objects that belong to this aggregate. I'm going to take a step-by-step approach, and I will try to explain all of the possible trade-offs to the best of my ability. Let's start by exploring and understanding the use case that is currently implemented as a transaction script, and we're going to see what options we have to start moving out some pieces of logic from this use case into our domain model. Now, the use case is called create meeting, and it does what you would expect it to. It's going to accept some input request object and then use this information to interact with our current domain model to try to create a new meeting, validate some business rules, and finally, when all is said and done, we're going to add this meeting to our database context because we are using EF Core and persist this to the database. Then we have some additional logic for sending some emails and synchronizing this meeting with an external calendar. Now let's go back to the top of the use case and let's see what is going on step by step. So we may as well start from the actual request object that contains the information that's needed to create a meeting. So you can see we have a title, description, when the meeting starts, how long it takes, but we also have some fields like meeting type, the participants, agenda items, and of course we have the organizer. Now inside of the handle method, we have some logic for fetching the organizer from the database, getting the meeting policy from the meeting policy service, which we obtain using dependency injection, and we use this information to do some initial validation. Then we're going to create a meeting, check if there are any conflicts for the meeting organizer, and throw an exception if that is the case. So you can see that instead of returning a result object, we are opting for throwing exceptions, and we would need to handle this exception somehow and translate it into something that we can return as a response. But this won't be our concern in this video, so we can just stick to throwing exceptions. Then we have some additional validation for the request participants. We have to check that each of these participants exists, validate if they have any conflicts for this meeting, and then check if we can actually add them to this meeting based on the logic that's inside of this method. And if all is said and done, we're going to add them to the meeting. We're going to do the same with the agenda items, and after we are done with all of the preconditions, then we can add the meeting to the database and persist it. Now let's also check this helper method here called canAddParticipant with role, because it contains some additional rules that we have to enforce. For example, based on the meeting type, we have a maximum number of participants that can attend. We also have to check the participant role and if they are allowed to join this type of meeting or not. There are some meeting types that enforce a unique role, so this is another check that we have to apply before we can add a participant to the meeting. And there is another helper method that is checking for any existing conflicts for the participants' meetings, and you can see it's just an EF Core query. Now we're going to discuss the efficiency of this implementation a bit later, but that's not going to be our main concern. Now let's go back to the top of our use case and explore our core entity for the use case, which is a meeting. If I go into the meeting type, you can see that this is what I would call an anemic domain model. It's just a class with a bunch of properties. We could even call this data properties, and you can see that both the getters and setters are public, which means that anyone in our system that obtains an instance of a meeting is allowed to change the values of these properties. Now, this could be a good thing in a simple application, but it becomes problematic when you need to enforce some business invariants. Now, what are these invariants that I'm talking about? We're going to go back to our use case and start exploring some potential problems that could arise because we are using an anemic domain model. Now, before we begin the refactoring, a heartfelt recommendation from me is to have a set of unit tests for the use case that you want to refactor. I have a create meeting test class with a few unit tests checking the main flows inside of this use case. And if you're too lazy to write these tests yourself, you can ask an AI coding assistant like Copilot or Claude using Cursor, for example, to generate these tests for you. And most of the time, if you give the AI some good instructions, you're going to get pretty solid unit tests that you can easily add to your codebase. I have a total of 9 unit tests for my use case, and if I try to run them from the Test Explorer, you will see that all of my unit tests are passing. So having a good set of tests before doing any kind of refactoring is something I very much recommend. And now let's actually focus on this use case and let's discuss how we can move from an anemic domain model to a so-called rich domain model that's going to help us encapsulate some business invariants and make our code more robust and less prone to introducing subtle bugs into our code base. The first tactical domain-driven design pattern that I want to explore is the concept of an aggregate. An aggregate is just another entity inside of your domain model, like the meeting type that we have here, but what makes an aggregate unique is that it controls and encapsulates the access to a cluster of related objects. In this example, we are controlling the access to the agenda items and the participants together with the meeting data. The value behind using this pattern is encapsulating your business invariants in one place. So if we take a look at the meeting class here, you will start to notice a few things. First of all, each meeting is closely related to the meeting policy. So you can see that these types are kind of interconnected. We can't really create a meeting without actually checking that the duration of this meeting for the given meeting type fits the meeting policy. So that's one thing that quickly catches my eye. The second problem that I see, and this is something that's sometimes easy to miss, is that the start time and end time have to be manually set. You can see that we set the start time directly from the request object, but the end time of the meeting is calculated based on the request duration. So what could happen is somebody instantiates a meeting and fails to set the end time value because it's not automatically calculated. And this would probably lead to some interesting bugs down the line. For example, when checking the time conflicts for a meeting that depends on the start and end time. So let's start fixing these problems one by one, and we're going to begin by encapsulating the meeting creation process inside of this type. You can achieve this by simply making the meeting constructor private. You can leave the meeting constructor empty, and this is also recommended if you are using EF Core. Now the next thing we need to do is to expose a way for someone to create a new meeting. So we can create a static method on the meeting type. We could also consider this a static factory, and what we would do is create a new meeting instance, for example an empty meeting, and we can return it from this method. And this allows us to move some of the logic that was previously inside of our use case into our domain model. So I'm going to copy the code that I had in the use case, and we're going to start filling in the missing parts. You can see that we are missing the title, the description, a date time object that represents the start time, and I'm going to start aligning these arguments vertically so that they can fit the width of my screen. The next argument we had is a time span object representing the duration of this meeting. Then we had a string for the location, and we had a meeting type. So let's also add that. And then I'm going to update the setters here to use these parameters instead of the request object. So let's update this calculation to use the start time and the duration. We can set the duration here directly, and also have the location and the type. So this allows us to move our logic from our use case into the domain model. And a side effect is that we have also encapsulated this invariant that automatically calculates the end time for a meeting based on the start time and the duration. So now whenever somebody wants to create a meeting, they have to specify the start time and the duration, and we don't have to think about calculating the end time because that's automatically taken care of. Now I need to go back to the create meeting use case and fix my compile error because I don't have access to the meeting constructor. Instead, I have to use this factory method. So we can omit the ID here, and we're going to leave the code that's required to satisfy the signature of the create method. So I have to specify the title, the description, the start time. We won't be specifying the end time because that's now inside of the factory method. We have to specify the duration, the location, and the request type. So this already simplifies our use case, which now only has to call the meeting create method without actually having to know what it takes to create a valid meeting instance. Now what I would also do is move this piece of logic here into my domain entity. So let's copy this code, for example, after creating the meeting, and then let's see what we can do about actually implementing this. I don't want to depend on the meeting policy service to obtain a meeting policy instance. So what I can do is simply accept the meeting policy as an argument. Then we can delete this piece of code here, and we can replace request duration with meeting duration. And now our code will compile. I will also replace this with meeting type. And instead of throwing the application exception, let's throw a domain exception to make it obvious that this is an exception arising from our domain. So now we encapsulated another business invariant into the meeting create method. We're taking care of setting the correct values on the meeting instance when creating it, which also means calculating the end time, but also we are taking care that the meeting duration satisfies the meeting policy. And this means that I can omit this piece of code from my use case. Now I have to pass in the meeting policy as an argument, and I can get rid of this validation here because it's now part of the domain. So this is what we are left with in the use case. Now let's focus our attention on this piece of code here that is checking for time conflicts for a given user and based on this meeting start and end time. If I go into the implementation of the check time conflicts method, you can see that it has a user identifier as an argument and a start and end time for a meeting. And we are using these values to check if there is any meeting where this user is one of the participants, and we are also using the start and end time to validate any existing meetings. What I don't like here is having to return a list of meetings to simply validate if any meetings with a conflict exist. So a better approach would be using any async, which won't load the meetings into memory, but this would mean we have to replace an enumerable of meeting with a boolean. So this would be a more efficient way to approach this. Now, when it comes to the signature of this method, we can also pass the meeting directly instead of specifying the start and end time. And then we can use the meeting end time and start time properties as the arguments in our link expression. But now we also have to fix the usage of this method inside of our code. So let's copy this entire method call here, and I'm going to directly use it inside of this if statement. So now all we have to do is just pass in the organizer ID and the meeting directly instead of having to specify a start and end time. And what you will notice is that even here, the end time was calculated manually, which could have led to some interesting bugs. So let's fix this, but we also have to fix this in the second call here. So let's go ahead and do that. I will replace this with just specifying the participant ID and the meeting directly, and this should solve our problem. At this point, we already made a few significant changes to our code, so it would be a good time to rerun our unit tests. And if I try to do this, you will see that I'm running into a build error because my unit tests are trying to instantiate a meeting instance, but I made the constructor private. Now, what I could do, and this would mostly be a temporary fix, is make this an internal constructor. The correct way to solve this would be to use the meeting create method, but let's not spend time on this, and let's just accept a temporary hack of using an internal constructor. And we are going to fix our unit test when we are done with the refactor. So you can see that our unit tests are passing, so our use case is still working as expected. Now let's see what are some other things that we can fix to further encapsulate our domain model. The next significant piece of logic that we have inside of our use case is this for each loop here that is responsible for validating the participants and adding them to the meeting. We are checking if the participant exists, if they have any existing time conflicts for this meeting, if they satisfy the rules that are required to add them into this meeting, and finally adding the participant into the meeting. So here's how we can approach this. I will go into the meeting aggregate, and the first thing I can do is to encapsulate the access to the participants collection. We can do this by creating a backing field, which can be a private read-only list of participants. Let's call it _participants, and we're going to initialize it to an empty list. And then we're going to make the participant property return a copy of this list by calling participants to list. And instead of returning a list type, I can update this to be an iRead-only collection. A read-only collection doesn't have methods that allow you to modify this collection, which is what makes it a good candidate for returning a copy of the participants. But now that we have encapsulated our participants, we won't be able to add any to the meeting, which you can see here inside of our use case. So what we have to do is expose a method that's going to allow us to add participants. So let's make a method on the meeting called add participant. And what do we need to instantiate and add a new participant? Well, inside of our use case, you can see that we are using the participant ID, the role, and we are automatically setting the status to pending. This is because the participants have to confirm that they will be attending the meeting, so this is also part of our invariants. So let's expose the arguments that are going to be a user identifier. We could also accept a user instance, but I'm going to keep it simple. Then we have a participant role, and let's just call this role. And we can go ahead and say participants add and create a new participant. And here we have to set the user identifier, the participant role to the respective value, and I'm going to set the participant response status to pending. And now I can go back to my use case and call the add participant method, where we are going to specify the participant ID and the role from the participant request, and now we are able to add the participant into the meeting. However, we also have some validation that we are doing in the use case that should definitely be part of this method call. So let's go ahead and copy this piece of code and let's paste it into the add participant method. So we first want to check if we can add a participant with a given role into this meeting. Now we already have the meeting, so we can omit the first argument, and the second argument is the role. So I'm going to fix this code slightly. I also want to throw a domain exception, and then this is what we are left with. However, we don't have this method. So let's go ahead and copy the implementation from the use case into our domain model, and we will see what we need to fix to make this work. So I'm just going to add this code here and update the signature to only accept a role. And then we have to fix it to work with the current meeting instance. Of course, this method can't be static in order to be able to access the meeting. And with these few adjustments in place, I should be able to make this code work. We can discuss refactoring this code further, but from a functional perspective, it does what we need it to do. And we have encapsulated this check as part of the add participant method. So if we go back to our use case, what we are left with inside of this loop is simply checking if the participant exists, if there are any time conflicts, and then adding the participant into the meeting. Now, if you're paying attention, you might notice that there is a subtle bug here because we have a meeting organizer that is also part of the meeting. They should be inside of the participants, but we aren't adding them to the list of participants anywhere. Now, we could assume that the request participants should also contain the organizer, but this might not be the case. And also, the add participant method sets the response status to pending, whereas an organizer would typically be automatically confirmed because they are the one creating the meeting. And this introduces an interesting problem that we need to solve. And a simple way how we could approach this is expose another method, for example, called add organizer, and we could set the participant response to accepted for the organizer type. Of course, specifying the role would be redundant, but another way how we could approach this, given that we are already verifying the uniqueness for given roles, which is this check here, validating if there is already an organizer inside of this meeting. So let's keep it simple and simply use the existing add participant method. But we're going to update the logic here that's going to check the role, and if the specified role is, for example, organizer, then the participant response status will be accepted, otherwise it's going to be pending. And back in our use case, after checking the time conflicts for the organizer, we can say meeting add participant and specify the organizer ID and the participant role as organizer. And this will take care of including the organizer as a participant in this meeting. So I'm pretty satisfied with what I have here. Now let's move on with our use case to the agenda items, which you can see here. So this is the logic for the agenda items. And what's going on here is we also have a collection of agenda items in our meeting aggregate. So this is a candidate for encapsulation, but we also have some logic here that calculates the total agenda duration based on the specified agenda item. And if the total duration exceeds the meeting duration, then we're going to throw an exception. So I'm going to copy the entire logic. So let's approach this one step at a time. For example, we can start by encapsulating the agenda items. And we can use the same approach that we were using for the participants. So I can say private read-only list of agenda items. I'm going to create a backing field, and then I'm going to make my property return an iRead-only collection. Let's make it return an agenda items copy by saying agenda items to list. And now I need to expose a method that will allow me to add agenda items to the meeting. So I can say public void add agenda item. And what I need to create one is, I think, a title and a duration. So we can specify that as the arguments here. So let's say title and then time span duration. And we can just say agenda items add new agenda item, and we're going to set the title property and the duration property. So this allows us to add agenda items to the meeting. So let's go ahead and say add agenda item. We're going to specify the title and the duration. But currently we don't have the logic in place that's going to allow us to check if the total duration for the agenda items exceeds the meeting duration. So let's also include this inside of this method and make it an invariant. We could choose the eager or the lazy approach. Let's go ahead and calculate the total agenda duration. So if we try to say agenda items sum and then specify the duration property, you will see that this is going to cause a compile error because there isn't an overload of sum that accepts a duration. So what you can do is instead specify the total ticks and sum those, and then use that to create a new time span instance. And this will allow you to calculate the total agenda duration, including the item that we are trying to add. And if that exceeds the meeting duration, then we're going to throw a domain exception. Otherwise, we can proceed to add a new agenda item. So back in our use case, we can just omit this calculation here, remove this variable, and all we have is iterating through the agenda items and adding them to the collection. Now, if we at some point exceed the meeting duration, we're going to throw an exception. And this is what we are left with inside of our use case. At the start of the use case, we are fetching the organizer, the meeting policy, and then using that to create a new meeting, checking for time conflicts for the organizer, and then adding them as a participant with the respective role. Then for each of the participants, we're also doing some validation and adding them to the meeting, adding the agenda items, and then storing this inside of the database. And then we are communicating with some external services to send some email notifications and sync to external calendars. So now I'm going to rerun my tests and see if anything is broken. And I'm getting some compile errors because in my test setup, I'm creating some initial participants. So what I will have to do is update this to use the add participant method and specify the organizer ID, and I can specify the participant role as organizer and then omit this step here. And it looks like we have another place in the code where I'm doing this, but instead of the organizer, this is the participant. So let's, for example, add them with a status of required. And now I should be able to build and run my tests. And you can see that a few of them are failing. I expect that this is mostly because I was throwing an application exception and my tests expect a domain exception. So let me see if this is the case. It should be the case here. And one more test that's failing, it is this one here, and I'm going to update this to be a domain exception. And now I'm going to rerun my tests, and you can see that they're all passing. So I didn't change any of my existing behavior in the use case, and I managed to move some of the logic that belonged to the meeting entity into the class itself. And this allows us to encapsulate our business rules into the domain entity and the respective methods, and it also helps us solve any issues with reusing this code inside of our code base. So whenever somebody wants to add an agenda item from a different use case, we have a check here that's going to validate that we don't exceed the meeting duration. The same for adding the participants and checking if we can add a participant with a given role. So this is the advantage of having this logic inside of our domain model. And if it were in the use case, then we would have to duplicate this logic across the different use cases, which isn't really scalable. And I find that approach error prone and is going to make it easy for us to introduce unwanted bugs into our code base. A few more options that we could explore here are introducing domain services for any logic that we consider to be part of the domain, but it doesn't naturally fit on the meeting aggregate. So this could be, for example, the check here for making sure that we don't have any time conflicts on the meeting. It could also be this entire piece of code here that requires us to add an organizer and a participant. Moving that into a domain service would make sure that whenever we create a meeting, we have to include both an organizer and any relevant participants. Another thing that we could explore is using domain events, which we can handle out of process and treat them as kind of notification events. And in reaction to these events, we could implement the publishing of the email notifications and the synchronizing with external calendars. Another thing that we could do from here is further encapsulate the meeting entity by making all of these setters private and exposing respective methods on the meeting type that are going to allow us to change these values in a meaningful way. But I think that the topics that we have explored so far are enough for this video, and you can let me know in the comments what you think about the approaches that I demonstrated here. Is this something you would use in your codebase, or do you prefer using Anemic domain models? Also, make sure to smash the like button if you enjoyed this video. And if you want to learn about the best practices for aggregate design, then you should watch this video next. Check out my clean architecture and modular monolith courses to improve your skills. Subscribe to my channel so that you don't miss any of my future videos. And until next time, stay awesome.